the some of the examples of your Nakamoto consensus algorithm by following the proof of work in that. So it has been just proposed that this proof of work puzzle can be designed in such a way that they serve two purposes. The first, the primary purpose is in the consensus mechanism, and second, to perform some useful scientific computations, like computing the hash algorithm or hash values. So this way, not only can the scheme be used in mining, but they can also help to potentially solve other scientific problems too. So this proof of work, which is used in this consensus method in the Bitcoin, this work has been recently put into the practice by the Prime coin also, not only along with the NOM. It's also used in the Prime coin. Where the requirement is to find the special prime number chains known as the what you call the Cunningham chains and between chains. So as the study of the prime number distribution has a special significance in scientific disciplines such as your physics, or by mining, prime coin miners not only achieve the block reward but also help in finding the special prime numbers. So in that way, the miners, they get the values. And as we discussed in the Nakamoto consensus, after receiving 6 blocks confirmation, then only those transactions will be added to your blockchain system. And we talked, this is a distributed consensus algorithm, and we talked it as a peer-to-peer network. It follows in this consensus. So, what is the drawback that you can find, or what are the different security measures for this proof of consensus comes? So, as we said that, suppose if we have few nodes like N1, N2, N3, N4, N5, and it is a peer-to-peer network, suppose connected. Okay, in this case, so we know that this the Bitcoin network, or the distributed network, any node can join the network at any time, and any node can leave the network at any time. Basic property, right? Second one is every time when the nodes join the network, they try to generate their new identity by using their public key. So every time new identity will be there. Whatever the previously used identity, that is not used any further. That is a concept of distributed network in Bitcoin. Correct? So in this case, what is the drawback? What is the security issues that may take place? Just guess. Is there any chance of doing the attack in the network?
I mean, one thought could just be you have like noise generation of various nodes constantly entering and giving out false reports saying, "Hey guys, look at this, look at this, look at this," and when before anything to be done to them, they leave the network and then change themselves slightly.
That's correct. Any other point? Yeah. The point which you mentioned, we called it as your, Sybil attack. As you know that any node that can, comes into the network and live into the network, suppose in that Bitcoin study consensus, the consensus algorithm which we discussed, you just recall that Bitcoin nodes do not have persistent long-term identities, right? Any long-term identities. So this is another, difference from your traditional distributed consensus algorithm. One reason for this lack of identities is that in this peer-to-peer network, suppose if it is a Bitcoin network, it is a peer-to-peer network, right? So there is no central authority to assign identity to these nodes. It's allowing that any node can enter at any time with new identity. So there is no centralized, central authority to assign these identity or the address for these participants, and to verify that they are not creating new nodes at will. So any node can join, right? So the technical term for this we call the Sibyl attacks actually. How? The Sibyls are just a copy of nodes that a malicious adversary can create to look like there are a lot of different participants, when in fact all these pseudo participants are really controlled by the same adversary. So assume that the N1 node can join with its entity, and after a few time, N1 node can join as N4 node, N1 node can join as your N3 node if it is connected. So then it assumes that these are all honest nodes. First, once N1 node entered into the network, its activities are like the honest node, so that other nodes in the network can believe that okay, it's a honest node. But at the same N1 node with a different ID, with new ID like N3 and N4, and join in the network. So what happens in the out of 5 nodes, 3 nodes are fake nodes, because same user controlling N1, N3, and N4. So what happens here? Then they start acting as a malicious node. Start acting as a malicious node. So that is the copy of N1 is called N3, the copy of N1 is your N4. So these are adversaries. So the other reason is that in this Sibyl attack we can say the pseudonymity in inherently a goal of your Bitcoin network here. So even if it were the possible or easy to establish the identities for all nodes or all participants in the network in this Bitcoin, we wouldn't necessarily want to do that because of its basic property of the network. So although Bitcoin doesn't give the strong anonymity guarantees in that the different transactions that one makes can often be linked to other, and it does have the property that nobody is forced to reveal their real life identity, like the name or IP addresses in the network, which are suppose given that 192 dot some 168 dot some 15 dot some 50. I know it may use the different identity for that. And in order to participate in this network, it requires identity. Either it can use the public IP, the public key or the IP address in the network part. And that's an important property and a central feature of Bitcoin's design actually. So in this, if node did have identity, uh, the design would be easier, but for starters, the identity would allow us to put in the protocol instruction of the form that now the node with the lowest numeric ID can start doing the or propose the new block in the blockchain system. So this we call it as your Sibyl attack. That is one of the major security issue in the proof of work of your the public consensus. So that is the attackers can simply attempt to fill the network with the client under its control, that entire network is under their control. So that creates the multiple identities. As said, the multiple public key addresses are used for hashing, for creating a new block, so to control the network, and it refuses the relay valid blocks or relay the attacked blocks by the honest users in the network. So the solution, the assume the proposed solution for this Sibyl attack is the diversify the connections. So that is the Bitcoin allows one outbound connection per the 16 blocks of your IP addresses. So that cannot make both the IP addresses like 202.161.81.2 by your 16. That means your 16 bits, first two bytes are used for the network address purpose. Remaining 2 bits used for your host identification purpose, we call the host address. So in this, it said that in the outbound connection for the any of the block of your IP addresses that cannot make both the having the same IP addresses. So that is one way of identifying the Sibyl attack. So another one is, as soon as you identify the malicious node in the network, the Sibyl attacker, it is to the honest nodes to remove those nodes from the network. That is the part of your certificate revocation process is required. That is one of the research area. Can anyone interested, they can go through that. The another one is denial of service attack. So what do you expect in the denial of service attack basically? What do you mean by a denial of service attack in this? Yeah.
You either, most generally, you target the server and flood it with traffic or block its connections to the rest of the network in an attempt to cause any traffic surrounding your target to ground to a halt.
Yeah, that's one point. In our blockchain, suppose, as we said that in a Bitcoin network or blockchain network, there will be multiple miners will be there, right? Who can do the difficulty computation. So then, by considering that scenario, suppose there are 3 miners are there in the network. How this denial of service attack can take place and whether it will sustain in the Bitcoin network or not.
Then you target the non-malicious miner group, and you attempt to cause any of the correct unaltered answers to be delayed to such point that your malicious block is computed, accepted, and put into the chain where, by the rules of the blockchain, it's too late at that point.
Yeah, that's a good point. Yeah. So if you recall that, suppose we have 3 miners, for example. Let's assume, what is the job of the miner? Let us assume the miner 1. We have another miner 2. We have another miner 3. Okay. So the role and responsibility of the miners, their activities in our Bitcoin network is they try to collect all the transactions which are broadcasted by the nodes which are existing in the network, right? So let us say that one transaction is broadcasted like transaction 1. So that transaction received by every miner in the network. So that will be placed into the block 1, the block which they want to create. Suppose miner 3 is trying to announce miner three's own transaction, suppose. So let us assume transaction 3. So that transaction 3 is received by every user in the network, and miner 3 is placing miner three's own transaction in the block. Okay, so that transaction, when it is broadcasted, that comes to your block miner 1 also. But if miner 1 wantedly not to include the transaction of miner 3 in miner 1's block, the proposing block. So this is intentionally. So what happens? So the miner 1 is having the only one transaction, and after that, suppose miner 2 is also announcing a transaction, that transaction 2 by your miner 2. So that will be included in the transaction of miner 3's block, and that will be included in transaction 2. In that case, when these blocks are going to, for the validation or confirmation of these transactions, suppose miner 1 is randomly selected for adding miner 1's block into the chain, what happens in that? These two blocks are ignored, and miner 1 block will be added to the existing blockchain. Suppose the previous block, let us assume B0, if this is going to be added, in this case, though miner 3's transaction is valid, but that is not included by miner 1, and that miner 1 block is elected to add to your blockchain. In that case, it is saying that miner 1 is wantedly denying service, providing service to your miner 3, because miner 1 don't like to give service to miner 3, so that is denial of service. So that is, there is a possibility. But what happens? For a limited time, this will be okay. After that, when your transaction miner 2 is suppose elected to add the blockchain, the block to that. In that case, miner 3 transaction will also be confirmed and valid, but for a period of time, wantedly with miner 1 denying service for including the transaction of your miner 3 into its own block. So that is the denial of service attack possibility is there, that they send a lot of data to a node is another way that they block the processing power and making other nodes too busy, making other miners too busy, so that they are busy with the unwanted transactions, and the sender, who is acting as a malicious node, can only take the honest node transactions and confirm, validate it, and add it. That is another way of doing the denial of service. Because to do the mining process, it requires some resources, right? CPU power, your processor power, power consumption, everything will be considered in that. So the solution for such kind of limitation will be like limit forwarding the blocks and disconnect a peer that sends too many transactions is one way. That means identify a miner or a node in the network who is sending more transactions periodically. More transactions, as we said that in every 10 minutes one block will be generated. Right? If anyone try to generate the blocks in 5 minutes or something, means there is some advisory nodes is there. So identify such nodes and try to disconnect them from the peer network is another way. And then breaking the proof of work is another concern. So that means in Bitcoin, proof of work is a computationally difficult, right? So that is the mining process to break, but not impossible. So in this is it the attackers can deploy the high power servers in the network, the basic attackers, and do more work than the total work of your blockchain. So what is happening? The honest miners, those who are creating blocks, if their computational power is less compared to any of the dishonest nodes, they try to create fake blocks. So with that, what is happening? When those blocks are creating and when broadcasted in the network for confirmation, every time it is a process in Bitcoin that at least 6 confirmation is required. If every time if 6 confirmation doesn't come, another block creates, another block creates. So what happens? It is breaking the chain. So that is possible, but it is not it is not impossible to find out those malicious nodes and disconnect from the network.
Yeah. Is another name for this attack the 51%?
Yeah. Yeah. So this breaking of your proof of work, that is also known as the case of your successful double spending, which we discussed that the Alice created some coins and the same coins are spent for two different transactions. So that's a problem. That is possible just because of these high power servers, because they get the chance to create the new block and add their own transaction which is already done with others, so that the used transaction can be included in the new block and the old transaction is simply removed from the block, so that there will be a chance of your double spending. So this is basically addressed in the year 2013. It was discovered that the gas input output mining pool that appears to be engineering in this Bitcoin. So you just go to this link for more information about this double spending part. So then comes to the another case of the monopoly problem in the what you call the public ledger or the distributed consensus algorithm. That is this proof of work that depends on the computing resources which are available to the miner. What is the computing power of the processor? What is the storage power of the processor? How much energy is consumed. So the miners, they have more resources that have the more probability to complete the mining process. If their servers or their CPU power is more, the processor speed is more, they can complete the process in a shorter duration. So what happens every time that miner who is having the more resources, that will become the winner and become the monopoly for that particular network. So this monopoly can increase the overtime or the tragedy for the commons. So these miners will get less reward over time. Every time they get they try to build a new block and add to the blockchain. So users will get discouraged to join as a miner, because only one miner having good resources. So getting to the network for getting more probability to complete the task. So few miners will be there in the network with the large computing resources may get control over the entire network. So that is a monopoly problem in this proof of work or the distributed consensus algorithm. So what is the solution? As said, the 50%, 51% of the attack, that is a group of miners. We call them as the black hat attackers. Also, there are the active attackers. They become into one group. As said that the single user, because of the there is no long-term identity, the single user may create the new users as with the same with new identity, but all these three nodes will be controlled by anyone, and they have more resources, so they become the miners in the network. And for every any other nodes which wants to be participate as a miner in the network, because of their lack of resources they will get less chance. So every time if these three nodes get the chance, then it will be, that will be controlled by entire network. And then your group of miners, they control more than 50% of the hash rates of your network here to creating the new blocks. So hypothetical as of now for this Bitcoin, uh, as the network is large, but not possible happened for the Cryptome, that is the Ethereum based blockchain, that is one of the application for your Bitcoin, that happened in 2016 year. So this is another, the security measure in proof of work. So based on these, the issues, there are certain limits for this proof of work. One is the limitations are derived as the good limit for this proof of work is it is a fully decentralized consensus for permissionless model. That is the good idea of this. Anyone can join the network at any time, and anyone can leave the network at any time by having their own identity, which is generated by their public key. So that works good for the cryptocurrencies, and the serves it is its purpose. But along with that, it has some the cons also. That is, do not trust the individuals, because they can, as said, have multiple identities and they can act as a malicious nodes. But trust the society as a whole, means as an entire network you can trust, but you don't trust any individual. Means at what time their behavior will be changed is don't know, because maybe some nodes, they are very honest during the joining of the network, and after a period of time they started assuming, why should I work as a miner if I'm getting a less reward? Suppose, why should I work as a miner? So if I decided that I shouldn't work as a miner, means I don't want to waste my power consumption, which is used for my machine. I don't want to use my storage or store all the blocks or copy of your ledgers, or I don't want to waste my processor lifetime. So then simply what I can do, I'll just deny the service, right? If anyone, though the transactions broadcasted in the network, I simply deny it. I don't want to, collect all the transactions and then assemble them into one block and then generate a new hash and make that a hash to your, previous block and then go for competition in the network. Why should I take all this break? Okay. But I mean, if any node in the network thinks in that way, then that will give you a denial of service. So that is, sometimes I'm honest, sometimes I'm the adversary node. So in that case, do not trust any individual in the network. But as a whole society, it is possible. So you need to the real large network to prevent at least 51% of your attack. So not to the all suitable for the enterprise applications, but it may suitable for some of the societies, closed societies. They come together doing this, the by following the distributed consensus algorithm with the proof of work. So in closed society, what happens after a random period of time, every node in that society trying to understand other nodes' behavior. Identity will be changed, but the behavior will be observed. That how many transactions that the node included and successfully confirmed it and added to blockchain. Yeah.
So just wondering, uh, who, who is doing the checking for that? Because is the point of the network to be
Every node in the network.
Okay.
Yeah.
So if we all see that, say, node one has done miner one has done 65% of all the blocks in the past FR.
Yeah.
How does the network come to a decision about that minor?
No, every time when it is going to add a new block,
Mhm.
what it is doing, it is collecting transactions from the network, right?
Mhm.
So those transactions are merged into, are assembled into one block, and that
Yeah.
block is broadcasted, right?
Yeah.
When that block broadcasts, then your transaction is also there in that block. My transaction is also there. His transaction is also there. His
Yes.
transaction is also there. So we are going to confirming that yes, this is my transaction.
Mhm.
How we are going to confirm? Because we are using digital signature, right?
Yes.
So when we confirm, so in that block, the limitation given that maximum 16 transactions. So out of 16 transactions, if at least 6 transactions are confirmed, then that block will be added. That means at least 6 users in the network should confirm, yeah, my transaction is there in minor one block. You also confirm. So that confirmation reply should go for that broadcasted block. So then it will be added. So next time maybe another minus block will be added, right? So there is no control. Anyone can add the block, but only transaction should be confirmed. So from this it is simple that at least 51% means 51% of your users should confirm that transactions are okay. Then that block can be added. So the ugly case of this, the limit of this proof of work is the low transactions throughput, and that is the overuse of your computing power. So in Bitcoin, 3.3 to your 7 transactions per second, whereas in Ethereum application it is approximately 15 transactions per second is allowed. So these are very low transactions of your proof of work, because it every time it needs to confirm by other users. So the millions of miners, and it gives the 1,000 tries, but only one get the successful chance. But every user's power, I mean the computing power will be wasted every other users. So those are a few limitations. So in Bitcoin energy consumption as of 2021, from taking a period of your the for 5 years limitation, 4 years limitation. In that case, the power consumption by the miners in this, gradually it is the increased, and the estimated with per year, as the power consumption is given, the estimated TWH per year is given. Gradually it is increased, means more number of users are allowed in that. So the carbon footprint, which uses like 825 by 0.47 kgs per transaction, so which is equivalent to like 137,578 hours of your watching YouTube time. So how much time consumption is done in that case, if you see. And it is, as it goes, the electrical energy in terms of computational power like used by your processor, so it is almost like 1737.32 kilowatts to per transaction it is used. That is equivalent to the power consumption of your average US household over 59.6 days. So this much, because as the block size increase, blockchain size increase, the computation power is also required. As we said, any transaction changes happens at the root level, at the leaf level node, it should reflect in the Merkle root level. So it must go through, update all the transactions. So more power is required. So this is about the proof of work, and what are the different types of attacks can be done by the attackers in the network. So in this proof of work, what is the basic thing which we are doing? They are trying to compute the what you call the hash, and then doing the difficulty computation, that is we call the mining process. So instead of that, The alternative to this proof of work, there is another consensus algorithm which is used in the distributed network and in the public network, that is proof of stake. The proof of the stake. So this proof is also called the virtual mining, the proof of stake, which is also called the virtual mining. So in this virtual mining, in proof of work, as said, to compute the proof of work that involves your CPU, you may use the GPU processors for that, your power consumption, or maybe your electricity. So these are, few what you call the entities involved in the proof of work. So that is related for consumption. So alternative to this, there is a another consensus algorithm we call proof of stake. This proof of stake is like virtual mining. So this is another type of mining puzzles like your proof of work that has been proposed as an alternative to the traditional proof of work scheme in 2011 by the member in Bitcoin forum, and they make a transaction from your proof of work to the proof of stake when bitcoins are widely distributed in that. So it was first proposed in the peer coin, as said, this proof of work. Like Bitcoin, there is a what you call the peer coin. It was introduced in that first in the year 2012. So in this scheme, the basic idea is that the users are required to demonstrate the possession of certain amount of currency coins they must own to be participate, thus proving that they have a stake in the coin. So the simplest form of stake is where mining is made comparatively easier for those users who demonstrably own larger amount of digital currency. So the benefits of this scheme are twofold. One is acquiring the large amount of digital currency is relatively difficult as compared to buying a high-end the application specified integrated service which can support for your GPU or the CPU purpose, the special purpose processors we call. So the second benefit, the compared to your POW, it results in saving the computational resources because having the high power CPUs in this case. So the various forms of your stake have been proposed and are briefly we try to address this case. One is your proof of coin age. You might have heard about that. The proof of your the coin age. Yeah. So the in this case, the age of coin is the time which is given for this. Since the coins were the last used or held. So this is a different approach from the actual form of your proof of stake, where mining is made easier for users who have the highest stake in the alternate coin. So in the coinage based approach, the age of your coin is reset every time a block is mined. So the miner is rewarded for holding and not spending coins for a time period. So this mechanism has been implemented in the as said the peer coin, which is combined with your proof of work. the network combined with your proof of work for doing the mining in a creative way. So the difficulty of mining the puzzle is inversely proportional to the coin age. So mining that, if miners consume some coin age using some coin stake transaction, then the proof of work requirements are the relieved in this case. So that is the basic advantage of that. So this proof of work has said that the probability of mining a block that depends on the work done by your miner, but whereas in proof of stake, it is the amount of the Bitcoin that the miner holds. That miner holding around 1% of your the bitcoins for doing the doing the mining job or the difficulty computation. So, as said in proof of stake, as we are saying that it provides the increasing protection because everyone needs those who wants to become as a what you call the I mean the miners, they must hold the some kind of coins, digital coins, that is that gives some kind of the security or protection to your network by executing an attack is very expensive in that case because more of their coin should be put into the stake. So you need the more bitcoins for that. So if reduced incentives for any attack is there, then the attacker needs to own majority of their bitcoin. So by that way, the network can be protected from the malicious nodes, or the attacks will have more efficient on the attacker's part. Because if they want to become an attacker, they need to spend more coins. Because if they spend more coin, they need to place into the the proof of stake as more coin, then they will become the miner. So if they want, if any attacker is there, means they need to spend more bitcoin and get less reward. So what is the use of that? So in that way, somehow it will reduce the attackers in the network and try to protect the network because of this stake. Yeah.
So, proof of stake isn't that I might necessarily have 5% of total bitcoins in my wallet at the time of this. It's I have in the proposed block 5% of it is my Bitcoin.
Correct.
Okay.
Yeah. So that's the one.
Uh-huh.
Yeah. So as said, the variance of the stake, you can see the randomization in the combination with the stake that is used in the NXT and your the block coins. So as we said, one of the approach is your coinage, that the number of coins multiplied by the number of days the coin have been held, which is used in the peer network, as we said. So another the variant is your proof of deposit. Another variant is your proof of deposit. So in this proof of deposit, the core idea behind this scheme is, which is another variant of your proof of stake, is that newly minted blocks by miners are made unspendable for a certain period of time. They must deposit. So more precisely, the coins get locked or seized for a set number of blocks during the mining operations. So this scheme works by allowing miners to performing the mining at the cost of freezing a certain number of coins for some time. So this is a type of your proof of stake, just like your the coin age. And another one is the another variant of your proof of stake is your proof of burn. So in this proof of burn, the miner should show proof that they have burned some coins to do the mining operation. to do the mining in this case. So,
What does burned mean in that context?
yeah, in the bond means, if you see, as we discussed that, the energy consumption is directly related to this one, right? So in this, the proof of bond, as you can say that this is an alternate expenditure to computing power is one, the computing power, and proof of burn in fact destroy a certain amount of your bitcoins in order to get equivalent alternate coin is one. That means to become a miner, you must give some of the coins. So this is commonly used when starting up a new coin. That project means to provide a fair initiation distribution. In that case, that I want to become a what you call the miner. In that case, we should spend in terms of mine. In the previous case, you need to deposit some amount means it will freeze for certain blocks, like for 2 blocks or 3 blocks like that. Whereas when we talk about the coin age means those coins will be used for doing the block adding new blocks for a period of time. After that, those coins should be renewed. It's one way stay, the proof of stake. This is burn means you need to spend some coins, basically some new coins, to become as you are the burner. So it should says that show the proof that they have burned some coins, so that send them to a verifiable unspendable addresses, that these coins are fixed. So the expansive, it is just like your proof of work, but no external resources are used under that bond coins. So this is also again one kind of freezing type. So this proof of work versus your the proof of burn, that the real resources versus your virtual or digital currencies. So you created a digital currency and that you freezed. Whereas in proof of work, the actual power consumption, electricity consumption, you need to purchase the high computational servers or machines, something like that. But in this case, you are using virtually. That means what? You are freezing, I have these coins, some transaction coins, and you are keeping them for doing mining process. So physical resources are not involved in that, in proof of burn one. Whereas in physical one, you are using the electricity power, or you need to purchase, some computational devices, servers like that. Yeah.
Do miners need to be burning every time they
Yeah.
mine?
Yeah.
Then why do I have miners if I'm forced to spend coins every time?
Not every time. In this case, yeah, every time it is means what? Suppose if you are getting good incentives,
Okay.
so then you will participate. If you are getting less reduction incentive, you don't.
But
Sure.
sorry, just wondering if I have good enough incentive, like if I've burned 5 coins, but should mine be taken, I get 6 coins. I guess my question is like, where's the security in that if I know that I'm chosen?
There is no security. That is
Okay.
why. Because that is what it is, a permissionless. So security issue. That is what we discussed.
Okay.
Any
Thank
kind
you.
of attack
Thank
can
you.
happen. Yeah. So this, proof of burn works by just burning proof of, the work mined cryptocurrencies. So that is, if you compare this proof of, stake and, proof of burn, suppose, then ultimately that depends on your proof of work, which is mined, the cryptocurrencies. So you cannot use them to, bootstrap from your new blockchain. So that is the key process. So another one is another the variant of your proof of stake is your proof of elapsed time. So in this proof of your elapsed time, that is proposed by the Intel as part of your hyperledger. When we talk about the hyperledger, we discuss more about this proof of elapsed time. With the sawtooth, they propose this consensus by your Intel in the hyperledger smooth in the permissioned what you call the network. So the blockchain platform for building the distributed ledger application, they use this consensus as proof of stake by giving the elapsed time in that. So the basic idea behind it is every participant in the blockchain network, they wait a random amount of time, so that we call the elapsed time. Then the first participant to finish, that become the leader of your new block. So for every participant, the random amount of time is given. Up in that time, they don't do any kind of operation, but after that, they can participate as a miner in that case. So how will one verify that the proposer has really waited that much time or not is a question mark in this proof of elapsed time. How it will be verified? So to utilize a special CPU instruction set that called the Intel Software Guaranteed Extension, which is developed by a hardware part by your Intel, to guarantee that is pre-programmed as soon as your device is entered into network by using that specific processor. So it is basically for a closed what you call the distributed network participants. So a trusted exception platform will be evaluated that whether really weighted or not. So that trusted code is private to the rest of your applications. So the specialized hardware which is provided an attention, so attestation that the trusted code has set up correctly. So it is a pre-programmed one. We also call it as your if I briefly say that you have ROMs, read-only memory, that is the pre-programmed one, or program controllers we say. So that is pre-programmed one. As soon as your the device boot ups, it automatically start executing, and its starting time and its elapsed time will be automatically gives as an the proof of elapsed time in this network. So this is the some of the alternatives of your proof of work. Alternative is your proof of stake. In that, these are the different phases: that proof of elapsed time, proof of deposit, proof of burn, proof of your the coin age. So these are different the consensus algorithms which are used in different networks, like in Bitcoin network, altcoin network. So these are a few of the examples and their difficulties. So blindly remember that it is a open network, so there is no guarantee for security because it is not controlled by any authorized or centralized users. But possibility is, because of the proof of work, there is a possibility of getting this network success for creating. Yeah, so that's all. I just want to stop the session here, and if you have